So, what is the point of a pointer? No pun intended. Well, according to this book written by the developers of C, a pointer is a variable that contains the address of a variable. Pointers are much used in C partly because they're the only way to express a computation, and partly because they usually lead to more compact and efficient code. Alright, so what does that exactly mean? So in the memory of a computer, you can imagine that we have a variable called pointer that points to a certain hexadecimal memory address in your computer. You can use pointers to make your code more efficient and give it functions that it otherwise could not have. Bringing our new pointer knowledge into real code, keep in mind that you can create a pointer for any data type, including void. We initialize a pointer using what's called the asterisk symbol and set it equal to the address of a variable using the ampersand symbol. If our pointer is equal to ampersand x, we then need to dereference our pointer in order to print out the value of x. The printed result, in this case, would just be the number 1. So taking a look at another example. Now let's say we remove our dereference operator and we change our format specifier to %p. The printed result will then be the memory address where our x variable lives. We can confirm this by printing out our ampersand x and see that the results happen to be the same. This makes sense given that ptr is equal to ampersand x. Now let's look at an example where we pass a value by pointer into a function. This works just like any other data type. We can specify conditions by seeing if our pointer is pointed to null or nothing. Sometimes we set our pointer to null in order to avoid memory leaks or dangling pointers. If our pointer is pointing to a valid address, in this case, it will print out the value at the address that it is pointing to using our dereference operator. We can now create a function called main. We can also create a variable called sumInt and see how our function behaves. Keep in mind as well that our value pointer 1 is already a pointer. Therefore, when we pass it into our function, we don't need to use an ampersand in this case. Looking now at our printed values, the first function call is going to print out pointer is null, while our second function call is going to print out the number 5. Up to this point, you may not understand why we choose to use a pointer over just passing in the actual value. Hopefully this example displays its usefulness. We can create a simple increment function with no return value that's supposed to modify a variable x. We can then create a variable called myvar, increment it, and wait for the printed result. Unexpectedly, we print out myvar and it is equal to 2. In order to avoid this behavior, if we change our function to pass in values by pointer, we can directly modify the value at that memory address by incrementing its dereference pointer so that our increment function gives us the expected output of 3. So why else would we choose to use pointers? Well, instead of copying an entire struct into a function, we can change the values at specific memory addresses. We can initialize a pointer of our struct type in this function and use what's called the arrow operator to manipulate member variables within the struct. This allows us to manipulate small bits of memory instead of copying around large chunks of data. We then initialize a struct in our main function, pass it in by pointer using the ampersand symbol. This allows us to print out our first element 10. This is easily the most common way to modify any elements found in a large structure, and is ubiquitous in the C programming language. The C programming language requires that we use pointers in order to take in user input. We usually use the Scanf function for this purpose. We can then create a pointer and have it point to the beginning of dynamically allocated memory. We cast what's called the Malloc function, memory allocation, as an int pointer and then specify the amount of memory needed, which is n number of integers in this case. In this example, if we want to take in user input but we don't initially know how much information the user is going to give us, instead of creating a static array with a set limit, we can dynamically allocate memory at runtime using the Malloc function and pointers. This will give us just the amount of memory that we need instead of overshooting by creating a massive array or not having enough memory for that user input. We can then use the user input as we please and perform various operations on whatever was given to us. The first loop multiplies the ith element by 2 as long as I is less than the user input, while the second for loop prints out the values. When using Malloc, you will also need to free up the memory from the heap in order to avoid memory leakage. In C, a string is really just an array of characters. When we set a pointer equal to an array, we are really just pointing at the memory address of the first element in that array. In this example loop, we say that while our pointer is pointing to a valid value that isn't the null character, we can print out each dereference pointer value and then increment our pointer to the next element in the array. We are essentially printing a character and then pointing to the next array element, printing that out and then continuing along until we reach the end. So once again, why pointers in C? Well, there's a myriad of reasons we would use pointers. Hopefully these examples helped you to understand why we need pointers in the C programming language. They really are a fundamental part to becoming a programmer in this language. I hope you guys enjoyed this video, and make sure to like and subscribe for more content just like this.